Hi everyone, my name is Kyle Hurst. My project this semester was on critical congenital heart disease for our genetics course. Okay, so critical congenital heart disease for description and characteristics. Critical congenital heart disease is a catch-all term for multiple heart defects that are present from birth. These defects are from problems with the formation of one or more parts of the heart. The multiple possible defects of critical congenital heart disease prevent the heart from functioning normally, resulting in the heart not pumping blood effectively, which may reduce the amount of oxygen in the blood. Most babies that have CCHD show early symptoms and require surgery directly after birth. Organs and tissues throughout the body don't get enough blood, which lead to organ damage, organ failure, stroke, coma, and death. Some symptoms include heart murmurs, not sure if I'm pronouncing this right, but I'll give it my best shot. Tachycardia, hypotension, hypoxia, and cyanosis. Other effects include reduced stamina during exercise and delayed development. And that might be kind of odd saying during exercise, but many people can go a long time without knowing they actually have CCHD. So, babies can go home and the parents not realize that they actually have CCHD until a later time in life. Inheritance. Inheritance is random because it occurs in people with no history of the disorder in their family. Since there are multiple heart defects associated with CCHD, mutations occur as autosomal dominant, autosomal recessive, or X-linked traits. Heart defects are the most common type of birth defect, accounting for more than 30% of all infant deaths due to birth defects. 7,200 or 18 per 10,000 newborns are diagnosed with CCHD each year. So here's just kind of a pretty basic pedigree that I drew. So I included some names and ages, and then just went down their tree to show who can get this disease. Again, parents not having the disease or no signs of it can actually be passed down, because this is actually a genetic disease that can happen just from a mutation. So this isn't something that's necessarily passed down from someone to somebody else, or pass a couple traits, but this is something that can happen at random, since there are multiple different genetic disorders with CCHD. So there are multiple different causes for this as well too. But there's just a kind of like a little generic pedigree that you guys can look at. Genetic testing. A genetic test called a congenital heart disease panel is available. This test goes through 42 genes and variants, testing for diagnosis, pre-symptomatic and therapeutic management. This test is looking for deletion and duplication analysis, and also sequence analysis of the entire coding region. The test is optional because most testing for critical congenital heart disease is done after the baby is born using a simple bedside test called the pulse oximetry. This estimates the amount of oxygen in the blood, or during pregnancy. During an ultrasound, usually tests are not recommended unless there's a possibility of the disorder, since most of the CCHD is affecting the heart. That's going to be the number one key thing that they're looking for when testing babies is the oxygen levels. So if their heart isn't pumping correctly, or their valves aren't working correctly inside their heart, there's not going to be enough oxygen inside their blood to produce those naturally movements, or when they're exercising at later dates. So that's usually the number one thing that they're looking for. Testing is usually done within 24 hours after the baby is born, using that pulse oximetry machine, and with an ultrasound called a fetal echocardiogram during the pregnancy. If there is a possibility of critical congenital heart disease, then there will be an option for panel screening, testing for multiple genes, testing for deletion, also analysis of the entire coding region. Early detection is extremely important if it is believed a baby has critical congenital heart disease. If diagnosed, some babies will require surgery or other procedures their first year of life. So this is something that's really serious, especially if it's not picked up early. This is something that they can plan for. They can plan on surgery, right when the baby's born or a couple days after, depending how serious it is. But this is definitely something they want to pick up on. Caution. Some babies born with critical congenital heart disease will appear healthy at first and be sent home before the heart defect is detected. These babies are at risk for having serious complications within the first few days of life and often result in need of emergency care. Timely care may prevent disability or death. So just another caution that this is something you really want to pick up on an early time and not find out later when it's not detected and maybe something goes wrong. So this is just an example of the pulse oximetry screening for critical congenital heart disease. So you can kind of go through the fail or pass 95% or higher in RH or F, and a difference of 3% or less between RH and F. That's going to be a pass, and a fail is 89% or lower. And you can see it. This isn't just one test that's done. To repeat the screen in an hour, then repeat the screen in an hour. So this is something that they test multiple times to make sure that their diagnosis is correct and the baby does have critical congenital heart disease. What companies perform the test? I found two companies called Invitae and Semaphore perform the test. The price I found was $450. I actually couldn't find it online, so I just called the company directly, and that's what they told me, is $450. I was pretty surprised. I thought it'd actually be more. But I include some links for the company information as well. Function of the mutated gene. Critical congenital heart disease is caused by a mutation in the ELN gene, more properly known as elastin. The elastin gene provides directions for producing a protein called tropoelastin. Tropoelastin proteins attach to one another and are processed to form a mature protein called elastin. Elastin is a major component of elastic fibers, which are slender bundles of proteins that provide strength and flexibility to connective tissue. Elastic fibers are found in the intricate lattice that form the space between the cells, where they give structural support to organs and tissues such as the heart, skin, lungs, ligaments, and blood vessels. I believe the intricate lattice is the space between the myosin and actin, and that's actually what's contracting. That's what contracts your muscles, your heart as well too. That's what's causing that to contract. Impacts of mutation. Changes in these genes are associated with critical congenital heart disease. I listed all the genes there. They can look over. The heart defects associated with CCHD can also occur as part of genetic syndromes that have additional features, including Down syndrome, Turner syndrome, and 22q11.2 deletion syndrome. Potential risk factors such as chemicals or drugs before birth, viral infections that occur during pregnancy, and other maternal illnesses such as diabetes, and again, I'm going to give this my best shot, phenylketonuria also increase the chance of the baby developing CCHD. And then here's a bunch of references where I found all this information. CCHD is something I hadn't really heard of before, so when we were deciding what we wanted to choose, it sounded really interesting to me. I've taken a couple anatomy and physiology classes, and I've always thought the heart was the most interesting part of the body to me. Just the valves and everything, how it works, the pressure gradient. So that was something I found really interested, and when I saw it, it piqued my interest. So I hope you enjoyed the video and maybe learned something. Thanks.